Good evening. Hello.
Yes, sir.
Oh, say today we should start another model. The previous first model we completed everything except one method of finding the eigenvalues, that is using Given's method. So that part we shall discuss later. Even though if you don't study, if you study other all other things, you can answer full question. So that part I'll take later. Today I'll start one more model. Hello. That's the third model. We shall discuss. Okay. Listen here. So in this model, all the topic given that all already you have studied in your degree class. That is, and also very simple one. These are called numerical methods or numerical solution for differential and integral equations. So two concepts you have to study. Sorry, three concepts. One is solving the initial value problems using the method mentioned here. That is Taylor series method, Euler's method, Euler's modified method, Runge-Kutta method, and Miller-Editor method. Using these five methods, you have to see how to solve initial value problem. That's one concept. Another is solution of integral equations. That means using some numerical method of integration, we are finding the integrals of some standard functions. That is using trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/3 rule, Wedel's rule, and least square approximations. So almost all method you have studied in your UG class. So it is just enough to just go through that. And one more concept is interpolation. That is using a particular type interpolation. That's Lagrange's interpolation. So these three concepts you have to cover in this model. Now, first we should start with the ordinary differential equations. That means it's first order, first degree differential equation. But we are not solving as I have studied earlier using theory part, but here only numerical solution you have to see. Numerical means at a particular point, what is the solution by knowing the initial condition of that problem. So this numerical process, let us see. First order, first degree differential equation. The first method is the Taylor series method. So I'm not explaining the theory part here, only how to solve problems. Mute, not Captain Mute. Hello. Disturbance. Equation. So consider the first order equation. It is given by usually dou by dt f of x comma y. First of all, you have to note that what this first order first degree differential equations represent. Usually, a first order first degree differential equation represent a family of curves under certain, there is the family of all curves under certain conditions is usually denoted by a differential equation. Here, differential equation is given, that is dou by dx is equal to f of y, which initial condition y of x is y naught. When initial condition is given, we can find the solution for this differential equation. Solution means here actually out not, there are two variables x and y. X is independent variable and y is dependent variable. X and y is given. That means a relation between x and y, it is given. That represents here the rate of change of this dependent variable y with respect to x. So dy by dx is equal to f of x y means the change in y with respect to x is given as a relation in between x and y. When this type of condition is given, y of x naught is equal to y naught means the solution of this differential equation is given at a point x naught. That means value of y at a point x naught is given. The process of finding the value of y for consecutive values of x like x1, x2, x3, where each side is equidistant. That means it is equally spaced. This process finding the solution, it is called numerical solution for this type of differential equation. Here, first let us see what is this Taylor series method to solve a first order, first degree differential equation with this type of initial conditions. When an initial condition is given, this type of differential equation is called initial value problem. So initial value problem is it's a differential equation with the initial condition. Here, to solve this differential equation, we usually use Taylor series method. So Taylor series method means, suppose that y of x, y should be a function of x, be the general solution of this differential equation. Then we can write this function as an infinite series. For that, we use this Taylor series. So how to write the Taylor series for any function y of x, if it is differentiable, about a point x naught is given like this. So we can write the Taylor series for this function y of x. Y of x means solution for the differential equation about the point x is equal to x naught as y of x is equal to, first you have to start the value of y at the initial point x naught, that is y naught. So first write y naught plus it has infinite number of terms. So each term is given by the first term is the value of the starting point, that means solution for the differential equation at the point y naught, that's y naught, plus then you add to this x minus x naught by 1 factorial into the derivative of that function at the point x is equal to x naught, y is equal to y naught. It is denoted by y0 dash. Y0 dash means the derivative of this function you find, that is dy by dx, or just write y dash at the point x is x naught. It is usually denoted by y0 dash. This is the coefficient of x minus x0 whole divided by 1 factorial. The next term is x minus x naught whole square by 2 factors into the derivative of this at the point x naught, that is not the first derivative, second derivative. So it is denoted by y0 double dash. So all these values you can obtain since the first derivative at the first point is first derivative is given, but the initial condition is also given. Using the initial condition, you can get all these values. Next term is x minus x naught whole cube by 3 factors into the third derivative of y at that point, that is x is x naught, y is y naught. You get all this point up to 4th order. When you write this terms up to 4th derivative, then it is called Taylor's series of 4th order or 4th order Taylor series method. So just get the derivative up to 4th derivative. If you have to write up to 4th derivative, you get somewhat a good answer for this problem. It won't give exact answer, but approximate answer is given by all these numerical methods. So here, when it is asked to solve this type of problem to get the solution, that means to solve the initial value problem under this condition, what to do using Taylor series method is that first write this series, then y naught is given, we can substitute by knowing y naught and this dy by dx. Dy by dx is given as a relation in terms of x and y. So dy by dx means it is nothing but y dash. For this y dash, put x is x naught, y is y naught. Then it gives the value of y0 dash. So this value you can find. Since y dash is known, if you differentiate this, it gives y double dash. Again differentiate y triple dash. Like that, successfully differentiate and at each, for each derivative, get the value at the point x naught. That gives this type of values, y0 dash, y0 double dash, y0 triple dash, like that. Continue like this. And all this, write this series. Once the series obtained, if you want to find the value of the, that means y at a particular point, put that value here. That gives the solution for this. So this type of solving this differential equation is called Taylor series method. But actually, this must be solved at a point very near to this. Suppose that x0 is given. If you want to find the value of y at x1, x1 is nothing but add a small number to x0, that is x0 plus h. H should be very small number. In that case only it gives the answer. So if you want to find a value, solve this one at a distant point, then what to do means you have to divide that interval into small equal parts. That is like this: x1, x2, x3, etc. Which xi must be at an equidistant. Then, by knowing x1, we can get the, by knowing the solution at x1, we can find the solution at x2. Then, by knowing the solution at x2, we can go for x3, where this xi is nothing but x0 plus ih. So, like this, the solution for this differential equation is obtained. That's called Taylor series method. So, only this derivatives you have to find. So, substituting this initial condition and also the values of the derivatives at that point, we can find the solution at a point x is equal to x0 plus h. You have to note this. This h should be very small. Then only it gives good answer. It is h is some 10, 20 means you won't give the solution. If you want to find the solution at that point, you have to divide this into small part like this, 0.5. If you take h is 0.5, first to find x0 plus 0.5. So it gives at that point. Again add 0.5. Get the solution at each step. At the end, we can go to that place. So this is the method of solving the differential equation by Taylor series method. Shall take one illustrative example. Suppose that is asked to solve the differential equation dy by dx is equal to 2y plus 3 into e power x, 2y into 3 times e power x with the initial condition y of 0 is equal to 0. By Taylor series method, you have to solve, and also it is initial conditions given, the value of y at 0, it is given. We need the solution at x is equal to 0.2. Point is very near to 0, so HCC can take 0.2 and you can get the solution for this. But if it is very large means we can't get the solution. We get the solution, but it will not be the exact value for that differential equation. So you won't get the good answer obtained only if this h should be very small. So here the question is to solve this differential equation under this condition. So first step is you identify what is x0, what is y0. So before that, we should write the formula to be used. There is Taylor series for this solution y of x. About the point x equal to x0, the Taylor series is given by y of x is equal to, that is y0 plus x minus x0 by 1 factor into y0 dash plus x minus x0 whole square by 2 factors into y0 double dash. Continue like this. You add up to fourth order derivative. Then it is the Taylor's fourth order method to solve this differential equation. So first make use of the given condition. What is given here? From this condition, dy by dx is equal to some relation in terms of x and y is given. The condition given is y of 0 is equal to 1. From that you have to note this point is x0, this is y0. So x0 is 0 here, y0 is 0. And at which point you have to find the solution? At x is equal to 0.2. Since x is 0.2, at this point you have to need the solution. From 0 to 0.2, the distance is 0.2. We shall take h is equal to 0.2 here. So I need the solution at x1. x1 is nothing but x0 plus h. h is 0 plus 0.2 means 0.2. So at 0.2, we can get the solution by taking h is equal to 0.2. So first we shall get the required values. It is given dy by dx is equal to 2y plus 3 into e power x. From there, we see that dy by dx means it is y dash. It is denoted by the symbol also. So y dash means dy by dx. So y dash is here 2y plus 3 into e power x. What we need is this term y0 dash. y0 dash means the derivative of that function at the point x is equal to x0 you have to find. That means whenever x is there in that relation, replace x by x0, y you replace by y0. So y0 dash is nothing but, in this relation, put y is equal to y naught, x is x naught. So it is 2 times y0 plus 3 times e to the power x0. But y naught means this return, this value, it is 0, the return, y naught is 0, x naught is here 0. So 2 times 0 plus 3 times e to the power 0. Here e power 0 means 1. So we get is 0 plus 3, 3 only. So y0 dash is here 3. Next you have to go for y double dash to get this term. Y double dash means differentiate y dash once again with respect to x. It gives the second derivative of this. So y double dash is derivative of 2y plus 3 into e power x. That is 2 times derivative of y. We can represent it by y dash plus 3 into derivative of e power x is e power x itself. So once you got the second derivative, you can find the value of that second derivative at the point x is x naught and y is y naught. It is usually denoted by y0 double dash. So y0 double dash is here, you replace y by y naught and x by x naught. So it gives 2 times y0 dash plus 3 times e power x naught. But y0 is, we have already written, it is 0. But e power x naught, that means x naught is 0 here, e power 0 is 1. E to the power 0 means that is always 1. So we get this one as y0 dash here written, that is 3. So it is 2 times 3 plus 3 times, this is 1. So 3 into 2, 6 plus 3, 9 you got. That is the second derivative. Next, go to the third derivative. Third derivative means differentiate the second derivative again with respect to x. So it gives to 2 times derivative of y dash is, it is y double dash plus 3 into derivative of e power x is e power x. So y triple dash is given by 2 times y double dash plus 3 times e power x. As usual, find the value of this third derivative at x is x naught, y is y naught. That means in this relation, replace y by y naught, x by x naught. So y0 triple dash is 2 times y0 double dash plus 3 times e power x naught. But x naught is 0 and y0 double dash is here 9. If you substitute it, it gives 2 times 9. This 2 times 9 plus 3 times 1. So it is 18 plus 3, it is 21. Third derivative got. Next, go to the fourth derivative. So fourth derivative is again differentiate the third derivative. So there is 2 times y triple dash plus 3 times e power x. Since the derivative is obtained, get the value of that derivative at that point. At that point means when x is x naught, what is y value you have to find? Here y0 triple dash is there. Sorry, fourth derivative. So it is given by this. Here put y, replace y by y naught, x by x naught. The same process, but y0 triple dash is 21. So this will be 2 times 21 plus 3, it is 45. So like that, in Taylor series method, by knowing this y dash, go and that means successfully find the derivative up to fourth order. And at every derivative, at each stage, find the value at the point x is x naught, y is y naught. These are denoted by y0, first derivative, second derivative, third derivative, fourth derivative. Get all these numerical values. This values you have to substitute in series. That only you have to do. So the series, Taylor series given by y of x is equal to, what is this? Y naught. Y naught is 0. So you can write it is y of x is equal to, first term is 0 plus x minus x naught by 1 factor into y0 double dash. But you know that x naught is here 0. So this becomes x minus 0 by 1 factor into y0 dash. That is 3. Plus the next term is x minus x naught. X naught is 0. So x minus 0 whole square by 2 factors into y0 double dash. This is 9. This value is substituted. And for the third derivative, x minus, this is 0. X minus 0 whole cube by 3 factors into next derivative is 21. This 21 substitute. Next x minus x naught. X naught is 0. So it is x to the 4 by 4 factors into the fourth derivative is 45. So like that, write this series. This is that Taylor series only, but the question is not to find the Taylor series. Our aim is to find the solution for that differential equation at the point x is equal to 0.2. So what you do is, using this method, after writing the series, you put x is equal to this value. If x is this value is very near to this x naught. 0 to 0.2 is very near, so I can directly substitute. So y of 0.2 is equal to, put x is 0.2, it's 0.2 by 1 factorial, substitute in every term, replace x by 0.2. And on simplification, see what the answer. Using calculator, we can simplify this. And if you simplify, you may see that this value is nothing but 0.80196. So like that, we can find the solution of an initial value problem. Initial value problem is a differential equation with the initial condition by Taylor series method. So very simple method you studied earlier. Just you have to recall the method, that's all. The same type problem will be asked here also, no change. But that only you have to recall how you did this one earlier. So this is called Taylor series method. So if you shall take one more example, suppose it's asked you to find the solution of the differential equation. dy by dx is equal to, it is x squared y minus 1. This is x squared y minus 1 with the condition y of 0 is equal to 1. That is, the initial condition is y of 0 is equal to 1, and you have to solve this by Taylor's method at the point x is equal to 0.1. At x is equal to 0.1, you have to find the solution is given at 0. Y of 0 is 1 means when x is 0, value of y is 1. This is the meaning of that. So at 0.1 is very near to that. Here also you can take h is equal to 0.1 because it is very small number. Now, first step is writing that series about the point x naught. It is given by this y of x is equal to y naught plus x minus x naught by 1 factor into y0 dash plus x minus x naught whole divided by 2 factors into, whole square by 2 factors into y0 double dash. Next is x minus x naught whole cube by 3 factors into y0 triple dash plus x minus x naught whole to the power 4 by 4 factors into y0 to the power 4th derivative. We are restricted to only up to 4th order. If you write up to 4th order, it will be always a good answer. So next step is identifying what is y naught, y0 dash, y0 double dash, etc. X naught is known, y0 also known. X naught is here 0. This is 0. Y naught is 1. So these two values are known. And you can identify what is y dash. Y dash means dy by dx. It is given as x squared y minus 1. So f of xy, the right hand side, is taken as y dash. Now from this y dash, find the value of y0 dash. That means y0 dash, how to get it? In the relation, you replace x by x naught, y by y naught. But here x naught is here 0. Whenever x comes there, x inverse in that term is 0 because 0 into anything is 0. So this will be 0 minus 1 you get. So y0 dash is here you get minus 1. So that is written here. Y dash is this much means y0 dash, it is minus 1. This dash represent derivative of y, that means dy by dx. Once again differentiate y dash to get y double dash. So y double dash is derivative of x squared y minus 1. A simple differentiation, when there is a product, they have to use product rule. So this derivative is first function is x squared into derivative of the second, that is y dash, plus the second function is y into derivative of the first, it is 2x. So if you differentiate this term, we get these two terms, and derivative one is 0. So that is what y double dash. But I need here the value of this derivative, second derivative at the point x is x naught, y is equal to y naught. But since here x naught is 0, whenever x terms exist there, that term vanish because of this 0. So here 0 into this one is 0, this also 0. So what we get, y0 double dash is here 0. Next, go for the next derivative, third derivative. How to get the third derivative? Differentiate the second derivative with respect to x. So it is y triple dash. So for the first term also you have to use product rule. For the second also you have to use product rule. For the first one, if you use product rule, first function is x square into derivative of y dash is y double dash, plus second function is y dash into derivative of the first, it is 2x. Plus, similarly here, this is the first function, I take it as 2x. 2x into derivative of y is y dash, plus this 2y into derivative of x, that's 1. This is the product rule for these two. But here 2xy dash is there, again 2xy dash comes. If you club it, it gives to x square y double dash plus sum of these two is 4x into y dash plus 2y. This is the third derivative of this function. And we need the derivative, third derivative at the point x is x naught, y is y naught. So put x is x naught and y naught, y is y naught means since here x is there, x naught is 0, so this term becomes 0, this also 0. So remaining is 2 into y naught, but y naught is here 1, so 2 into 1 will get 2 only. So y0 triple dash is 2. But up to third derivative is not enough. Usually you have to find the derivatives up to fourth order. So fourth derivative means once again differentiate this. Again, as usual, product rule, this x square into derivative of y double dash is y triple dash plus y double dash into derivative of x square is 2x. So 2x into y double dash you get. Again, product rule for this, 4x into y double dash plus y dash into derivative of 4x is 4. So this term you get plus derivative of 2y, that is 2y dash. Now, common terms, similar terms. So it is x square y triple dash is there. Here 2x y double dash, 4x y double dash. If you add it 6 times x y double dash you get, and the sum of these two, 6 times y dash. Now we have to find the value of this derivative at x naught, y naught. If you put x is x naught, this term is 0, this also 0, 6 into y0 dash you get. But y0 dash is minus 1. So 6 into minus 1, all this term becomes 0, so get minus 6. So the fourth derivative at that point is minus 6. So once these derivatives are obtained, you can go for the series. What the Taylor series, it is given by y of x is equal to y naught plus x minus x naught by 1 factorial into y0 dash plus x minus x naught whole square by 2 factorial into y0 double dash. Continue like this. Is the Taylor series for the solution function up to fourth order. Now x naught is not, x naught is here 0. Substitute x naught by 0, so we get this series. But if you simplify what you get, this 1 here is x by 1 factor into minus 1, it's minus x by 1 we get, and here x cube by 3 factors that, but 3 factors means 1 into 2 into 3, so we get 6. If you multiply 2 here, 3 is only remaining. Simple calculation, so it gives this much. 4 factors means 24, 6, 4 times we get, but the sign will be minus. We get this Taylor series for the solution set about the point x naught. Now, to get the solution at the particular point, it's asked to find the solution at x is equal to 0.1 means put x is equal to 0.1 here, it will give the answer. So y of 0.1 is, question asked us to find the value of y at x is equal to 0.1. So that is 1 plus it is 0.1 plus 0.1 whole cube by 3 plus etc. Continue like this. So if you add it using calculator, you can see this value. So it gives to 0.90033. So this is the solution for this differential equation using this Taylor series method. So here, shall take one more example also, because only simple methods are there, 3-4 methods. The Taylor series RK method like that, all are on the same method, small changes only. Now we shall take one more example, that is to find the solution of the differential equation. This is using Taylor series method. Here also question asked to find the solution for y at the point x is equal to 0.1. That you have to note. If it is very small number means then only can apply Taylor series. If the question is to find the solution at x is equal to some 0.6 using Taylor series means you want to give the good answer. In that case, instead of finding at 0.6, there you take x is equal to some value. It will be 0.1 or 0.2 like that. If you take x equal to 0.1, then first get the solution at 0.1, then the solution at 0.2. You can continue like this. But at every stage, you have to get this derivatives. But it will be time consuming. Usually they ask the solution at a point which is very near to x naught. So as usual, first identify what is x naught. Here also x naught is 0, y naught is 1, and y dash is here, f of xy. That means the right hand side is x minus y square. So first find the value of y dash at the point x is x naught, y is y naught. It is obtained by putting x is x naught, y is y naught. Here also x naught is 0, y naught is 1. So 0 minus 1, so we get minus 1. Next, differentiate this. to get the second derivative of y dash, second derivative of y. So y double dash is derivative of x minus y square. Derivative of x is 1 and it is y square is 2y into derivative of y. It is 2y y dash. Again, find the value of the second derivative at x is equal to x naught, y is y naught, which is denoted by y0 double dash. So we get is 1 minus 2 times y0 means 1, this is 1, y0 dash is minus 1. So this is 1 into minus 1 and this minus 2. Minus of minus becomes plus. So 1 plus 2, it will be 3. Next, third derivative of this. For the next derivative, you have to differentiate the second derivative, but derivative 1 is 0 minus this 2 is constant, take outside, y double dash is there. For this, use product rule. Product rule is first y into derivative of y dash is y double dash plus y dash into derivative of y is y dash. So we get this term, which can written as this minus 2. This is y into y double dash is there plus y dash into y dash can written as y dash whole square. Now find the value of this derivative at the point x is x naught, y is y naught. If you substitute it, we get y naught is here 1, this is 1, y0 double dash is this 3, this will be 3 here, plus y0 dash is that, that's minus 1 whole square, means plus 1 again. So total it is 3 plus 1 into minus 2, it is minus 8. So that is the value of y0 double dash. Similarly, you can get the fourth derivative. Just differentiate this one again with respect to x. This minus 2 is common. For the first term, use product rule. Y into derivative of double dash is y triple dash, right? Plus y double dash into derivative of y, that is y double dash into y dash, plus derivative of y dash whole square, that is 2 times y dash, this is done, into derivative of y dash, that is y double dash. But these two are on the same terms, similar terms. If add it 2 and here 1, total we get 3 times y dash, y double dash. This is what the fourth derivative of y. Now put y is y naught, x is x naught, y naught is 1, the triple dash is here minus 8, it is y0 dash, it is minus 1, this will be y0 fourth derivative, sorry, this one is third derivative, this is third derivative, sorry, the second derivative is here written, that is 3. Substitute all these values. So what we get is minus 2 into minus 8 minus 9, this is 3 into 3 we get. So total 34. These are the values of the derivatives. Next, as usual, first write the Taylor series. That Taylor series will be same always, that is y naught plus x minus x naught by 1 factor into y0 dash plus x minus x naught by whole square by 2 factors into y0 double dash. Here x minus x naught whole cube by 3 factors into y0 triple dash. Continue like this. And here also x naught is 0. Always x naught need not be 0. If it is 0, we will get easily that terms. If it is not 0, that value of right. Suppose that x naught is 1 means here you put x minus 1, this will be x minus 1, this will be x minus 1, like that. Where you are expanding the series, that point you have to write. Don't think always it will be 0. Here only in all this problem you have taken 0. So since x naught is 0 in this case, we get that series as y of x is equal to 1 minus x we get, then 3 by 2 means 1.5 into x square we get, minus this 4 by 3 into x cube. If you substitute all this constant, you get it. So first you have to get the series, then where we need solution, that value you have to give to the variable x. We need the solution at x is equal to 0.1. So put x is 0.1. So y of 0.1 is in the series, put x is equal to 0.1. So simple calculations required. Use your calculator and see what this value. Just simplify this. And you may see that answer for this is 0.9139. That's the solution for this differential equation. Now to get practice, you take a somewhat problem of this type and try yourself. So I given some example here. So first question is to solve dy by dx is equal to e power x minus y square. with the condition y of 0 is equal to 1, and we need a solution at x is equal to 0.1. This is very near to 0. At this point you can find. Similarly, next question is dy by dx is equal to x square plus y square. The initial condition is y of 0 is equal to 1. That means x naught is 0, y naught is 1. And the solution I need at x is equal to 0.1. All the solutions, or for all the problem, solutions are required at the point 0.1 only. And the initial condition same here for all this, only changing the functions. Just get the derivatives and get the solution for this. This is what Taylor series method. Now I'll give one question introduction to another method that is called Euler method. There are two methods in the given syllabus, two more methods. One is Euler method, another is modified Euler's method. So don't confuse with Euler method and modified Euler method. Actually, Euler method is a slow process, and here you won't get a good answer also. To modify this, another method is introduced, that is modified Euler method. Usually in the exam, they ask modified Euler's method only. But in the beginning, you should know what is this Euler method. So consider the initial value problem. Usually it is given like this. Dy by dx is equal to f of x comma y. With the initial condition, y of x naught is equal to y naught. Usually they give the condition like this. Then, here the method is, actually there is a solution curve for this. Solution is a relation in terms of x and y. We call it as y is equal to y of x. In this method, the solution curve is replaced by the tangent to the curve at that point. We just replace curve by a tangent. When that value of x is very small, we get an answer very near to that. So how to get the solution is here at x naught solution on at a point x1. How we get x1? That is x naught plus h. Add a small number h to x naught to this point. At that point, the solution you have to give. It is given by, let it be denoted by y1. How to get y1 means it's very near to this one. So y naught plus slope of the tangent. Usually dy by dx means what it represents dy by dx. It is nothing but slope. So derivative meaning is finding the slope. So this is slope here. What is dy by dx written? F of xy. So value of the slope means at that point x is x naught, y is y naught. See what happens to this. Multiply by h, add to this. That will be the solution for that. By knowing the solution at x1, we can go for the solution for x2. How we get x2? Yet x naught plus h is x1, x1 plus h is x2, x2 plus h is x3. Continue like this. So the iteration formula for this Euler method is this one. To get a solution at n plus 1th iteration, see the solution at the nth iteration, add to this the slope of that, that means value of the function at xn, yn. That means the answer you got in the previous iteration, multiply by h. This is the iteration.